welcome to our channel. We have already discussed about the quadrilateral figure. Also discuss about the parallelogram figure. In parallelogram, we discuss the difference between the quadrilateral and the parallelogram. So that will make you little more aware about what is the shape of a quadrilateral and what is the shape of a parallelogram and what is the exact difference between these two figures. And what are the different points which are very distinct to this figure. Now we are going to start a new thing or new topic, that is on rectangle. And again we will follow our same pattern. We will discuss the difference amongst these three, that is quadrilateral, parallelogram and the rectangle. Having discussed these three, then we can proceed for the another figure. So let us not waste our time and let's start our discussion. Now let us understand the difference among these three figures. What is the meaning of a quadrilateral? What is the meaning of quadrilateral, parallelogram and a rectangle? So please understand, quadrilateral is a figure which is bounded by four lines. Both the sides are opposite and not equal. So let's say if these are the lines, both the sides are opposite and both are not equal to each other. So this is a quadrilateral. In a parallelogram, both the sides are equal, means this side and this side and this side and this side both are equal and parallel to each other. It means it never meet when you are extending this line. So that is called parallelogram. In a rectangle, opposite sides are equal and parallel. So up to here the definition remains same with the rectangle and parallelogram. The only difference does it create that each angle is of 90 degree. So when you draw a rectangle, both the lines are parallel. So this is a parallel, this is also a parallel to each other, and the opposite lines are equal to each other. Plus the angle that it makes is all 90 degree. So here you can differentiate between the parallelogram and a rectangle. Next, in a quadrilateral, diagonal 1 is not equal to diagonal 2, correct? In a parallelogram, diagonal 1 is not equal to diagonal 2. But in rectangle, diagonal 1 is equal to diagonal 2. So let's say when you draw a rectangle figure and you draw a diagonal, and if this diagonal is 10 centimeter, then this diagonal is also 10 centimeter. Next, all angles are not equal to 90 degree, means this angle, this angle and this angle and this angle. All angles are not equal to 90 degree. In parallelogram, all angles are 90 degree, and in rectangle, all angles are 90 degree. In quadrilateral, diagonal 1 is not perpendicular to diagonal 2. When say not perpendicular means it doesn't make a 90 degree angle. So I can read the same thing in a different manner. Instead of using not perpendicular, I can say diagonal 1 does not make a 90 degree angle with diagonal 2. Same is the case, same thing here, diagonal 1 and here also it is same. And diagonal 1 and diagonal 2 in rectangle cut each other equally. So let's say this is diagonal 1 and this is diagonal 2. So up to here it is 5 centimeter. If the total is 10, then 5, 5, 5 and 5. Next, when you connect the midpoint of the quadrilateral, The figure that creates out of connecting the midpoints of a quadrilateral is a parallelogram. When you connect the midpoint of a parallelogram, you will get a rectangle figure, and when you connect the midpoint of the rectangle, you will get a figure rhombus. We will discuss each thing in detail, but this is just as a beginning, or you can say the essence of the entire chapter. And D1 and D2 bisect equally. Now, again the idea about the rectangle. So let's say if I draw a rectangle, figure. So let's say this is A, this is B, this is C, and this is D. So what does it mean? AB is equal to CD. This side is equal to this side. And AC is equal to BC. So both opposite sides are equal. Next, AB is parallel to CD. So this is parallel to CD, side is same, and AC is parallel to BC. AC is parallel to BC, and these sides are also same. And the third important point, this is 1, this is 2, and third important point, it creates a 90-degree angle. It creates a 90-degree angle. So creates a 90-degree angle. More thing, when you connect C to B, a diagonal 1, and A to D, diagonal 2, so fourth point, diagonal 1 is always equal to diagonal 2 in a rectangle figure. Now look at here, this is a rectangle where A, B, C and D. This is our diagonal 1 and this is our diagonal 2. So D1 is equal to D2. Diagonal 1 is equal to diagonal 2. So let's say AC is 10 centimeter, then DB is also 10 centimeter, because it is a rectangle, and in rectangle diagonal 1 is equal to diagonal 2. And when the diagonal 1, let's say this is diagonal 1, cuts the diagonal 2, here it is not perpendicular. Here it is not perpendicular, means it does not make an angle of 90 degree at the intersections point of the diagonal. Now why diagonal 1 is equal to diagonal 2? Why? Diagonal 1 is equal to diagonal 2. So let's say this is a rectangle figure, right? A, B, C and D. And if I draw a diagonal, now if this is 10 centimeter, this is also 10 centimeter. If this is 5 centimeter, this is also 5 centimeter. And if I apply a Pythagorean theorem, then what is Pythagorean theorem? dB square means diagonals 1, dB is equal to, this is your L square, this is your B, so B square. And if I draw another diagonal like this, AC, so AC is equal to, now if you look at this figure, the L is 10 centimeter and base is also 5 centimeter. So L square plus B square. So this DB is nothing but diagonal 1 and this AC is nothing but diagonal 2. Therefore, D1 is equal to L square plus B square is equal to diagonal 2 L square plus B square. Now L square and B square is gone. Therefore, diagonal 1 is equal to diagonal 2. Next, D1 and D2 bisect equally. So, what does it mean? It means that when you draw a triangle like this, when you draw a triangle, then this is A, this is B, this is C, and this is D. This side is equal to this side and this side is equal to this side. This side is parallel to this side and this side is parallel to AB. Clear? And when you draw a diagonal in it, when you draw a diagonal, then this is the point of intersection. So what happened? This is diagonal 1 is equal to diagonal 2. It means this side is equal to this side and this side, and this is same size. So all these four sides are equal. So you can say D1 and D2 bisect equally. Now AB is parallel to CD, that we have already observed, and AB is also equal to CD. It means what you are going to get, you will get an alternate angles are equal. So if I draw a line like this, then this is the alternate angle, and if this is this angle, then this is equal to this. So X and Z, let's say when you draw this angle, if this is X, then this is also X, because as per alternate angle. And if this is Y, this is also equal to Y. When two angles are equal, then the third angle is also same. So this is Z, and the vertically opposite angle is also same. It means X, Y and Z are also equal to each other. It means what we are going to get? We are going to get angle, 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 triangle. Means this is called congruent triangle. Number 3. Diagonal divide the area of rectangle into half. Because let's say this is 10 centimeter, this is 10 centimeter. If this is 5 centimeter, this is 5 centimeter. And when you draw a diagonal, DB diagonal, then what is going to happen? The entire area is divided into 1/2 and 1/2. What is the area of a triangle? It is L into B. So area is 5 into 10. So area for the entire triangle is 50. So this is 25 centimeter square and this is 25 centimeter square. Because the diagonal will divide the entire rectangle into two equal parts. So AB is equal to CD and AD is equal to BC, and diagonal is for, let's say this is the triangle, and when you draw a line, this line is a common line. This line is a common line for both triangle 1 and triangle 2. And when the two triangles are congruent, so triangle 1 is congruent to triangle 2. The moment you look at this figure, then whatever is here, same will be here. Area of T1 is equal to area of T2. Side of T1 is equal to side of triangle 2. perimeter of T1 is equal to perimeter of triangle 2. So when you get this figure, this sign, congruent sign, then both the triangle are same. Both the diagonal of a rectangle divide the area into 4 equal parts. So let's say if this is a triangle, A, B, C and D, and when you draw one diagonal from D to B, this is your diagonal 1. So when you draw a diagonal 1, what is going to happen? It will create two triangles T1 and T2. And when you draw another line, so what is going to happen? This T1 will be divided by 2 and this T2 will be divided by 2. So 1/4 area, 1/4 area, 1/4 area and 1/4 area. Why is it so? Because the diagonal will bisect equally each other. Bisect means when they cut each other, then the length from here to here and length from here to here are equal, and length from here to here and length from here to here are also equal. So DB, let's say this is a DB line, D and B. If DB is 10 centimeter, then DO is 5 centimeter and this is also 5 centimeter. Then AC is 10 centimeter, this is A and this is C, is 10 centimeter. Then AO is 5 centimeter and OC is 5 centimeter. If any point is between the rectangle, here point 0, let's say this is a rectangle and you are taking one point here, and then you will connect this point from the vertex of the rectangle. So this is the vertex A, vertex B, vertex C and vertex D. And when you connect from all these vertices, then what is going to happen? It will divide the entire rectangle into 4 areas. This is area 1, this is area 2, 1, 3 and 4. But this is not a diagonal. Remember, this is not a diagonal. You can put the point anywhere, here also or here also. And when you connect this point to the vertex of the rectangle, then what is going to happen? A1 plus A3, these 2, is equal to A2 plus A4. So remember, A1 and A3 opposite to each other triangle. So A1 is opposite to A3 and A2 is opposite to A4, are equal to each other. Why? Now when you draw a two diagonal, let's say when you draw a two diagonal, then what does it create? It will create triangle 1 and triangle 2. So let's say this is triangle 1 and this is triangle 2. So area of AOB plus area of COD, CO and D. Now what is the equation of an area? It is the base means L and this is the height, blue line. This is the height, H1. And same is the area of a triangle is 1/2 into base into height 2. Height 1 and height 2 is equal to the base. So we can write 1/2 into L into B. And we know the formula of the entire rectangle to find out the area of the entire rectangle. It is nothing but the L into B. And what we found, the area of these two triangles is 1/2 into L into B. Next, if any point O is there inside the rectangle. So let's say you connect the point O inside the rectangle, and when we connect the point O with the vertices, so this is vertex is B, this is vertex C, and this is vertex D. So OA, this green line, OA, OC, OA plus OC, OA plus OC, this line OC is equal to OB, this line, plus OD, this line. Now the question may arise why? Because when you have a figure like this, and then whatever the way you are connecting the figure, so what you need to do, you have to draw a perpendicular. Perpendicular means straight line. So if I want to draw a perpendicular in this figure, this is a perpendicular. So perpendicular is a straight line, and here also it is a perpendicular. So this entire line from Q to S is perpendicular 1, and P to R is a perpendicular 2. So when you do this, then what is going to happen? Our Pythagorean theorem is going to come into the picture. So AO, that is the hypotenuse, is equal to AS plus OX square. So if you do for all this triangle, what you are going to get? OA square plus OC square is equal to OB square plus OD square. Are you clear? So for example, if this is a point, then OA square is OC square. So OA, so one vertex is down and one vertex is up. Then OB, one down and one up. So this is the equation. Point number 7. When we connect all the midpoints of a rectangle, then the figure we are going to get. So what is going to happen? Let's say A, B, C and D is a rectangle, and P, Q, R and S is the midpoint of the sides. And when you connect this midpoint, when you connect all these midpoints, then this figure P, Q, R, S is what type of figure? Now, if you remember, if there is a triangle, so let's say this is a triangle, this is a triangle, and this is the entire base of the triangle. Let's say this is the triangle. Then this line is actually the half of DB. This line SP is 1/2 of DB, because this is the proof we already studied in a triangle. So when you do all this stuff, what you are going to get? You are going to get the opposite sides are equal and parallel to each other. Then you will think that figure is rectangle or parallelogram or a rhombus. But here remember, both the diagonal do not cut each other at 90 degree. If it is a 90 degree, then it is a rectangle, but it is not a 90 degree, so it is a rhombus. So please understand, a rectangle, the inside figure is rhombus, whereas in quadrilateral the inside figure is parallelogram, and in parallelogram the inside figure is a rectangle. So remember this thing. Point number 8. Let's say this is the alternate angle x and x, y and y. They are equal to each other. So the diagonal in a rectangle are not angle bisector. If it is a bisecting, then it will divide this angle into half and half. But it is not a angle bisector. So when you are having an angle bisector, because we know the entire angle is 90 degree, and when you divide exactly at 45 degree and you draw a line, so what you are going to get? You are going to get triangle DOA. Next, let's say this is a triangle AB, C and D, and when you put a midpoint of AB is P and midpoint of side DC is Q, and then you connect the Q with A and P with C, and then you draw a diagonal. So when you draw a diagonal, you will see there are three parts of the diagonal. Number 1 is DS, number 2 is ST, and number 3 is TB. So what is going to happen? These three pieces of a diagonal are equal to each other. So DS is equal to ST is equal to TB. Next point, when you draw a triangle within the rectangle, then what is going to happen? The base will remain same and height will also remain same. So here base remains same, height also remains same. Here also the base remains same and height will also remain same. Here also the base remains same and height is remaining same. And what is the area of the rectangle is L into B. And what is the area equation of a triangle? So area of a triangle is 1/2 into base into height. Next question. Let's say this is a triangle A, B, C and D, and you draw a rectangle like this. So we know it is half, and when you draw another rectangle from A to E and from E to D, so there are two triangles, right, in this particular figure, and then it is given the area of D, R and F is 3 cm square. Then the area of FQEC is 20 cm. Then the area of BPE is 6 cm. Then what you need to do? What you have to do? You have to look at the figure which is covered by the triangle pink. So 1, right? And then this is 2, then this is 3, then this is 4, then this is 5, then this is 6, then this is 7, and then this is 8. Then look at this figure. Look at this figure. What is not mentioning is you have to mention over here. Then what is going to happen? This 1, 7 and 5 is covering half of the area of the rectangle, and then 3, this triangle 3, 7 and 8, you see it is coming under this triangle, so that will cover another half area of the rectangle. So when you put together 1, 7 and 5, 1, 7 and 5 plus 3, 7 and 8 is equal to the full triangle, full area of the rectangle. So full area of the rectangle is 1, 2, 3, 4, 5, 6, 7 plus 8 is equal to 1 plus 7 plus 5 this plus 3 plus 7 plus 8. Now what is common you have to remove. So 1, 1 is common, 3, 3 is common, then 5, 5 is common, 7, 7 is common, 8 and 8 is common. So here 2 plus 4 is equal to 7 number. So 2 is, we already know, it is 2 centimeters square, and 4 is 20 centimeters square. So the remaining figure is 20 centimeter square. Next, if there is a triangle A, B and C and D, and if P is the midpoint and Q is the midpoint on line CD and P is the midpoint on line DC, and when you connect this vertex A with this point, then you have to always remember the length of this PQ, is always half of the DC. So both the triangle becomes similar. So when there is a similar triangle, then remember the side ratio of a similar triangle is always is equal to 1:2, and the area ratio of the area of a similar triangle is 1:4. It means the small triangle, the area is 1, and for the big triangle the area is 3. So 1 plus 3 is 4. Area of half of the triangle is 4, means, let's say if this is a triangle, so if this is 4, then this is 2 and 2. So if this is half, then this part is also half. So let's say this is a triangle ABCD. So triangle 4, and then you put a line over here. This is a midpoint line. So what is going to happen? The total area is 4. So this small is 1 and this bigger is 3. So total area is 4 plus 3 plus 1. So this is 8. If we connect the median of the area is divided into half. So let's say this is triangle 1 and this is triangle 2. And if you are connecting to the median, then this 4, the total is, we know, this triangle ABD is 4. And if you divide the 4 into 2 equal parts, so this is 2 and this is 2. And this is triangle 2, so this is 2 and this is 2. So here we are completing our chapter number 3rd, and that is on the rectangle. Please understand all the concept and do all the example. Thank you very much.